Good morning and welcome everyone. Today's class. This is lecture number 4 in alternating current. What have we discussed so far? In the previous classes, we have discussed the various type of series circuit. We have discussed RL circuit. We have discussed RC circuit, and we have also discussed LC circuit. Today, what we'll do is we will go on and do LRC circuit, which would be the combination of all the three elements. But before going on to LRC, which is the combination of all three, let us first go through what we were doing in the previous class. And if I am correct, I asked you, or we were what? We were doing we were doing a table in the previous class, a table that has all the three elements, and we were writing the or discussing the difference between the three types of circuits. So let us go and do it. Here we have different terms. Oops, where did this go? Let it be here. Here we have different terms. The heading of this column was different terms. This is the LR or RL circuit. This is the RC circuit, and this is the LC circuit. I hope everyone understands this. This is my current source, AC source, and we had seen that same current, though it is not in the same phase, same current will flow in all the three cases because it is a series circuit. We had already discussed point number 1. I hope you all remember this. We have already discussed all these points. What we are going to do here is just write all these points together. Point number 2 is the phasor diagram. Phasor diagram for LR circuit, as you can see, VR is in phase with current, but VL is 90 degrees ahead of current. That is VL. This becomes your total V. This becomes your total V. Total V is ahead by a phase angle of phi. V square here will be VR square plus VL square. This is one way of writing it, or you can write it in terms of impedance. Z square is equal to R square plus XL square. We have already seen this, yes or no? So you can write it in terms of voltage as well, or you can write in terms of Z as well. In terms of Z, you can write Z square, which is the impedance, will be equal to R square plus XL squared. We have already seen that. As far as this phi goes, as far as this phi goes, as far as this phi goes, we have seen the value of cos of phi, the value of cos of phi is always equal to R by Z. Do we remember this? I hope all of you remember this. Tan of this phi, if I write tan of this phi here, will be equal to XL divided by R. I hope all of you understand this. This is everything drawn in one diagram. Now, if I go to RC circuit, my Z square will become R square plus XC ka square. Again, here, this angle would be phi. Voltage will be lagging current by an angle of phi. If someone asks you what is the value of this cos phi, the value of this cos phi will be again equal to R by Z. The value of tan phi would be equal to XC, which is 1 by omega C divided by R. LR and RC circuit are the two circuits that will come. In very rare circumstances, you might find this LC circuit. So what happens in this LC circuit? This is the current. Voltage across the capacitor will be behind by 90 degrees. Voltage across the inductor would be ahead by 90 degrees. So total voltage V will be equal to VL minus VC. If VL is more than VC, the ऊपर वाला VL is more than नीचे वाला VC. So the total voltage will be written as VL minus VC. If VC is more than VL, if VC is more than VL, then the total voltage will be VC minus VL. In any case, the angle between voltage and current would be 90 degrees. If VL is more, then VC voltage will be ahead by 90. If VC is more than VL, voltage will be behind by 90. I hope you have understood this. I'll give you a minute to note it down. I can't hear you, I can't see you, but I hope I'm there with you. A minute to minute. I hope all of you have written this down. We have discussed all of these. The only thing we did not discuss was LC, and I told you LC may not come at all. It is very simple as well. Let us now move on to the next point. And the next point is already discussed: phase difference between voltage and current. Phase difference between voltage and current. In a LR circuit, voltage will lead current by a phase angle of phi. cos phi is R by Z, tan phi is XL by R. We have discussed this. In RC circuit, voltage will lag current by a phase angle of phi, cos of phi is R by Z, tan of phi is XC by R. We have already discussed this. Now here is the thing that you must remember. In a LC circuit, if XC or VC, you can write it as VC also. If VC is more than VL or XC is more than XL, please remember, please listen to me carefully. If VC is more than VL or XC is more than XL, नीचे वाला is more, ऊपर वाला is less, downwards is more, upwards is less, then the voltage will lag current by an angle of minus pi by 2. Why it is written minus pi by 2? Because it is behind, that is minus pi by 2. But if XL is more than XC, or you can say VL is more than VC, voltage will lead current by a phase angle of pi by 2. Please remember this. If this question comes, this will be a very difficult question as far as the standards are concerned. If you can do this, well, you will get 4 marks plus 4, and that plus 4 will get you your dream college. A minute to win it. Please note this down. We have already noted this down. I'll give you a minute to note it once again if you want. And now we come to the final stage. And the final stage is where we have graph. And remember, a question in AC, it may not be a numerical question, but there is a high chance that the question involves graphs. To understand the concept correctly, you should be able to solve or answer this. Please remember this. If you don't understand this, remember this. We've already discussed this. And I'll give you a minute before going on to these graphs. A minute to win it. Note down this. You've already noted this down. I hope, bacha, you have noted this down. I have given you enough time. The most important thing, graphs. The most important thing, graphs. The most important thing, graphs. Variation of Z. Z means impedance. Z means impedance. When frequency increases, Z increases, and this is how the graph is. Remember when it was a series circuit? No. Remember when it was a pure L circuit, the graph was a straight line. When it was a pure L circuit, the graph was a straight line. When it was a pure L circuit, the graph was a straight line. I hope you remember it. I hope you remember it. I hope you remember it. Let me see if I have the graph here. So I'll show you the graph again. Let me see if the graph is there. When it was a series, when it was, see here. See here. Graph. Most important aspect, graph. A purely resistive circuit. The graph with frequency of R is straight line. The graph does not change. For XL, it is straight line like this. For XC, it was like this. Remember these graphs. This was for pure R. This was pure R. this was pure L, and this was pure C. But now what we are doing is LR, RC, and LC. I hope you remember this graph and you have drawn this graph. Graphs are very important because a question will come. It will be based on graph. They might not give you numerical on this. They might give you a graph on this. It's a question of +5 or +4 or -5. You remember that. This is the graph for LR circuit. R is also there. And therefore, the graph is not straight line. The graph is like this. When frequency increases, impedance increases. At very low frequency, you can assume that XL is 0. So the value of Z is approximately equal to R. Remember, Z in this case is equal to under root of R square plus XL square, R square plus XL square. XL is equal to omega L. If omega or angular frequency or frequency is very low, very low, very low, XL becomes 0 and the value of Z almost becomes equal to R. Almost becomes equal to R. But when the value of Z, no, when the value of XL is very high, when the frequency is very high, low frequency, XL is 0, high frequency, XL is very high, R remains same. So you can take that at very, very high frequencies, the value of impedance will be approximately equal to XL. Remember this. A straight question will come on this. Please solve it correctly. I hope you understand this. Similarly, for a RC circuit, when the frequency increases, Z decreases. Ooh, like this. Ooh, like this. Remember, Z here is equal to under root of R square plus XC square, and XC is 1 by omega L. So when omega increases, 1 by omega C, sorry, when omega increases, XC decreases. At very, very, very low frequencies, at very, very low frequencies, you can see here low frequencies, R remains same, but XC becomes very high, XC becomes very high, and therefore the value of Z becomes approximately equal to XC. But at very high frequencies, XC becomes very low, R remains same, and therefore the impedance becomes equal to R. And you can see at high frequencies, XC, at high frequencies, Z is equal to R. Here at low frequencies, Z is equal to R. In case of a LC circuit, when frequency increases, Z first decreases, then C first increases because XC is very high in first case and XC is very low in the second case. At very low frequencies, this becomes approximately equal to XC. At very high frequencies, approximately becomes equal to XL. I'll give you a minute, 2 minutes. I hope you have noted this down. The graphs. What is the graph of RC? The first one is the graph of RL or LR. Second one is RC. The third one is LC. I hope we have understood this. Remember these graphs. Straight away question will come. You can just take it away. 2 seconds and you are done. Now is the time. The time has come. The time has come. For what? For what? For what? The time has come to move on to the last circuit. If you understand this circuit, you understand all circuits. Understand one, and you are done. Because this consists of all the three elements. It consists of all the three elements. All the three elements is consist of. Let me just make it. It consists of all the three elements, and here it comes on your big screen. LRC circuit. LRC circuit. So, okay, now it looks good. A series LRC circuit. This is my voltage source. Everyone knows this voltage source. We have L, we have R, we have C. LRC. Now, why did I say that? If you understand this, you understand everything. If I take C out, it becomes LR. Yes or no? If I take L out and C is still in, it becomes RC. If I take R out, it becomes LC. If I take both R and C out, it becomes L. If I take L and R out, it becomes C. If I take L and C out, it becomes pure R. What is the summary? What is the moral of the story? That if you understand this circuit, you understand everything. I hope you are following me. I hope you are following me. I hope you are following me. So this is my current. This is the voltage across the resistor. It is in the same phase. This is the voltage VL across the inductor, 90 degree ahead. This is the voltage across the capacitor, 90 degree behind. Now, remember, there are three cases possible. Case number one, XL is greater than XC. Or I can say VL is greater than VC. ऊपर वाला is big, नीचे वाला is small. XL is greater than XC. XL is greater than XC. XL is greater than XC. Then what will happen? You will have something remaining on the top. Something always remaining here. And in this case, voltage will lead current by an angle of phi. Because this will effectively now behave as a LR circuit. XL is more than XC. XL is more than XC. XL is more than XC. Something will remain on top. Something remains on top and one is like this. So the voltage will lead current. I hope everyone is clear with this process. In this case, the impedance will be R square plus XL minus XC whole square. Voltage will lead current by a phase angle of phi. Everyone understands this now. Tan of phi Tan of phi will be equal to XL minus XC. Remember, in case of RL, it was XL by R. In case of RC, it was XC by R. And now it is XL minus XC by R. Do we all understand this? Can I have some raised hand that we understand this? Oh, can't raise your hands. I hope you have understood this. So this is case number one. This is case number one. This is case number one where XL is more than XC. And I'll give you a minute to win it. Case number one. 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 I hope you have written this. I hope you have written this. Now we'll just move on to case number two. What will happen in case number two? In case number two, XC will be greater than XL. Very simple. Or I can say VC is greater than VL. In this case, ऊपर वाला is smaller, नीचे वाला is bigger. So नीचे वाला will win. The downward will win. That means it will behave as RC circuit. It will behave as RC circuit. In this case, the impedance Z will be written as, I hope you know this, I know that you know this, R square plus, in first case, if you can see, it was XL, oops. In first case, as you can see, it was, okay, this will not happen. In first case, where if you see it was XL minus XC square, and now it will be XC minus XL square. I hope you understand this. Here, voltage will lag current. Voltage will lag current by a phase angle of phi. Voltage will lag current by a phase angle of phi. Here also cos phi. Cos phi is always equal to R by Z. Here also cos phi will be equal to R by Z or Z. If I talk about tan phi, my dear kids, बच्चों, tan phi. Remember, in a LR circuit, it was XL by R. In RC, it was XC by R. In LRC, case number one, it was XL minus XC by R, and now it is XC minus XL by R. I hope this is making sense. XC is more than XL, so it is XC minus XL by R. Voltage will now lag current by a phase angle of phi. This is more than enough that you must know. I'll give you a minute to win it. I hope you have noted down case number 2. Case number 1, XL is more than XC. Case number 2, XC is more than XL. What remains, my dear friends, is the last case. And what is the last case? No prizes for guessing. No prizes for guessing. The last case is XL and XC are same. XL and XC are same. XL minus XC is 0 or XL is equal to XC. This condition is known as resonance. You might have heard about resonance. This is known as resonance. At resonance, XL is equal to XC. When XL becomes equal to XC, omega L becomes equal to omega L becomes equal to 1 by omega C. 1 by omega C is XC. From here, you can find out the value of omega. Omega is known as resonant angular frequency. You can also calculate frequency F. Remember, the relation between frequency and omega is omega by 2F. So frequency becomes 1 by 2 pi root over LC. This frequency is known as resonant frequency. I hope you understand this. What happens with Z? Z is the impedance. Impedance Z is root over R square plus XL minus XC. XL and XC are equal. So impedance becomes R. It is equal to R. So this behaves as a pure resistive circuit. The more information you have, the better it will be for you. This is the graph of impedance Z versus omega. It decreases, then it increases. At resonant frequency, the value of Z is minimum, and that minimum value is always equal to R. The value of maximum current is maximum when the frequency is resonant frequency. I hope all of you are understanding this. XL is equal to XC. This condition is known as resonance. Omega, the angular frequency of resonance is 1 by root over LC. Frequency of resonance or resonant frequency is 1 by 2 pi root over LC. Impedance is minimum and current is maximum. I'll give you a minute to note this down. I'll give you more points on resonance in the next slide. A minute to note this down, because most of the question that comes on LRC are simply based on resonance. If you understand resonance, everything is done. I hope you have drawn the graph. Don't worry, I'll show you the graph again. I want you to note it down point by point, and here comes all the points that you must remember. At resonance, XL is equal to XC, point number 1. BL is equal to BC, point number 2. Both are same thing. Current and voltage are in the same phase, so this behave as a pure resistive circuit. This circuit behaves as a pure resistive circuit. This circuit behaves as pure resistive circuit. Impedance is minimum, the values are maximum current. Current is also maximum, and the value is V by Z or V by R. Please note this down point wise. straight away question will come based on these points. A minute to win it. I hope you have noted these 5 points, very simple points. I hope you have noted them. If you just note these 5 points, 99% of questions will come from this. The other half will be what is the resonance frequency? XL is equal to XC, omega L is equal to 1 by omega C. So omega squared becomes 1 by LC. Omega of resonance becomes 1 by root over LC. Frequency of resonance, some people call it FR, some people call it F naught, doesn't matter. It means the same thing. The resonance frequency is 1 by 2 pi LC. I'll give you a minute to note this down. Well, I hope you have noted down resonance frequency. Don't forget this. Then I come to the graph that I already shown you, the graph of Z versus F, impedance versus F. This is the graph. Z first decreases, becomes minimum, value is R. This is the value at resonance frequency. Then it increases. I hope you have seen this graph. I'll show you the graph bigger so that you can now easily draw it, and then I will show you what to write. So this is the graph in big, this is the graph in big. I hope you can see this now. This is the graph in big. No, you are not able to see this. I have to increase this. Probably have to increase this. Increase this. Okay, this is the graph. Z first decreases. On this side of the graph, it behaves as RC circuit. Or let me rub it, and so that I can show you. Oops, why is this happening? Let me rub it. Let me rub everything off so that I can show you. Now look at this point. The first point is the red point. The red point is the impedance is minimum and the value is R, and this happens at resonant frequency. I hope all of you understand this. I hope all of you understand this. I hope all of you understand this. This is the condition of resonance. Impedance is equal to R. Now I go to the left hand side of this diagram. On the left hand side of this diagram, why the color of this pen did not change? Okay. On the left hand side of this diagram, which is blue color, on the left hand side of this diagram, blue color, your XC is more than XL. Your XC is more than XL. I hope you can see this. I hope you can see this. I hope you can see this. your XC is more than XL, your XC is more than XL, and therefore this blue graph behaves as a RC circuit. This blue graph behaves as a RC circuit because frequency is low, frequency is low, frequency is low, frequency is low, frequency is low. XL is more than X. XC is more than XL. Look at the green portion of this graph, and I will draw it here. Look at the green portion of this graph. Look at the green portion of this graph. At high frequencies, XL is greater than XC, and this behaves as a LR circuit. I hope all of you understand this. I hope all of you understand this. Please draw this graph in the same way that it is drawn here. You can write on the left hand side, XC is more than XL, RC circuit. On the right hand side, XL is more than XC, RL circuit. Left hand side, low frequency. Right hand side, high frequency. Beach wala is the resonant frequency. Or I can say, if frequency F is greater than F naught, if frequency F is greater than F naught, it will come to the green side. It will come to the green side. If frequency F is more than F naught, for the blue side, frequency F, why did this not become blue? Why did this not become blue? Okay. On the left hand side, my frequency F is less than F naught. If frequency F is less than F naught, it behaves as RC circuit. If frequency F is more than F naught, it behaves as LR circuit. A minute to minute. I hope you have understood this. I hope you have drawn this graph. And then this is the explanation. If F is less than resonant frequency, XL is less, and it behaves as capacitive circuit, that is the blue part. Then if F is F naught, XL is XC, this is resonance, phase difference is 0, impedance is minimum, the red part. Third one is F is more than F naught, XL is more than XC, it is inductive. This is the graph of Z versus F, and here is the graph of I versus F. The graph is always ulta. Current first increases, reaches maximum. The maximum value of current is V by R. You must remember this. I hope you have drawn this graph. Two more small things that you must note from this graph, and I'll make it smaller, the current wala graph, so that you can see the current wala graph more better. And this comes the current wala graph in a better state. Now, as you can see here, this point is your resonant frequency. The current is maximum. Then there are 2 points, F1 and F2, where the current is I max divided by root 2. Please draw this graph. This is F1 frequency, this is F2 frequency. The difference between them is known as delta F. So this is what you need to draw in this graph. I hope you will draw it correctly. I hope you will draw it correctly. I hope you will draw it correctly. Just draw this graph and you might have a question just based on this graph. Draw this graph. You will have a question based on this graph. 2 graphs between Z and F, between I and F. I max, maximum current happens at frequency, resonant frequency. Then there are 2 frequency on the right and left where the current becomes I max by root 2. At this I max by root 2, you can also write power becomes maximum power divided by half. Divided by 2, not half. At these points, the power is half because current is I max by root 2. Power is I square R, so power becomes half. Power becomes half at these 2 points. Power becomes half at these 2 points. And what I'm going to tell you next is what you will remember and not forget, because it is all about remembering. You will remember this because a straight question will come and you will have to answer this. Remember this graph and the straight question that will come. You will have to remember these terms. Half power frequency, the frequency at which power becomes half. I've shown you that point. Bandwidth, that delta F is known as bandwidth, F2 minus F1. Q factor, quality factor, is 2 pi, maximum energy stored divided by maximum energy lost. Remember this. Q factor represents the sharpness of resonance. Remember this. Unitless, dimensionless. Remember this. What is the value of Q factor? It is XL divided by R or XC divided by R. It is 2 pi into F, resonant frequency, into L by R. So I can write it as 1 by R root over LC, or I can write it as resonant frequency divided by bandwidth. You'll have to remember all these formulae for Q. A straight away question can come. What you have to remember? Again, I'll underline it. You have to remember what is half power frequency. Power becomes half of its maximum value. Where does that happen? Those points where current becomes maximum current by root 2. Bandwidth. What is bandwidth? That difference is bandwidth. What is quality factor? This is the first formula of quality factor. It represents the sharpness of resonance, unitless and dimensionless. I'll give you a minute to note this down. Then I will make the formula bigger so that you can see it in bigger space. Note down whatever I've highlighted. Note down what I have highlighted. Do it fast. Note down what I've highlighted. Do it fast. Quality factor. It represents the sharpness, unitless, dimensionless quantity, maximum energy stored divided by maximum energy lost. And then these are the formulas that you must remember for quality factor. XL at resonance divided by R, or XC at resonance divided by R, 2 pi into resonant frequency into L by R, or you can write it as 1 by R into L by C ka root. FR stands for resonance frequency. You can write it as F naught as well. Depends on how you are writing F. You can write it as F naught or FR, resonance frequency divided by the bandwidth. These are the formulas that you must remember. I hope you have noted down these formulas. Then there are some golden key points that you must remember. The more you remember, the better it is. Series resonance circuit gives voltage amplification. It amplifies voltage. Parallel is not in your course, so you might not remember this. But parallel resonance circuit gives you current amplification, not in your course. If you want, you can remember this. At resonance current does not depend on R and C. It only depends on R and V. It does not depend on L and C. At half power frequency, net reactance, inductive reactance and capacitive reactance is equal to net resistance. Simple 4-mark question. As R increases, bandwidth increases. To obtain resonance, the following parameters can be altered. How can you alter the resonance? You can alter the value of L, you can alter the value of C, or you can alter the frequency. 4-mark question. This might not be of so important because this is very tough. 2 series RC, you can just leave it. I don't want you to get confused. This is not for you. This is for JEE. Leave it. The series resonance circuit is called acceptor. 4-mark question. Parallel is called rejector. 4-mark question. The unit of root over LC is second. 4-mark question. So we'll note down whatever I have underlined. You'll get 2 minutes for this. Well, I hope you have noted this down. Now what we are going to do is we'll solve some simple question. As you can see, questions are very, very simple compared to what we have done in the class. So this is the first question that we are going to do. A 50 hertz AC source of 20 volts. So the voltage here is 20 volts. This is 20 volts. Is connected to RNC as shown in the figure. The voltage across R is 12 volts. What is the voltage across C? That is what you have to find out. I'll give you a minute to win it. I'll be very happy if you can do this. Now the question is, how are you going to do this? Well, I just wanted to make a point, and that is why I've done this question. Remember, we know that Z is equal to root over R square plus XL square if it is RL, XC square if it is RC, XL minus XC or XC minus XL ka square, depending on XL is more than XC or XC is more than XL. Here it is simply equal to XC square. We all understand this formula. This is the formula of RC circuit. Now, similar to this formula, I can write another formula. Total voltage V will be equal to root over what? Now, you can't speak, so there is no mic. So, I'll speak on behalf of you. Z is equal to R square plus XC square. On similar note, V will be equal to VR square plus VC square. Now I told you about Pythagorean triplets. Total voltage is 20. Total voltage is 20 is equal to under root of VR square 12 square plus VC square. Remember, Pythagorean triplets. 3, 4 and 5 are Pythagorean triplets. If I multiply all by 4, 12, 16 and 20 will be Pythagorean triplets. I can see 20 here. I can see 12 here. You have the answer. Questions are always made in such a way that somehow they come to this Pythagorean triplet. Do we understand this? I hope we understand this. So the answer is the Pythagorean triplet, and the Pythagorean triplet is 16 volts. So the answer is 16 volt. What you got to remember is whatever formula I made for Z, the same formula can be made for V. I hope all of us are understanding this. I'll give you a minute to note it down. I hope you have noted this down. Since you have noted this down, this is a simple question that is coming your way. This is AIM 2000 question. The impedance of a circuit when a resistance R and inductor L are connected in series. Please show me. Please tell me your answers. And I guess answer is pretty simple. And answer is R square plus XL square. XL is omega L ka square. Omega is 2 pi f. So 2 pi f into L ka square. And therefore the correct option is C. C is the correct option. I hope you got it. C is the correct option. C is the correct option. Now, the last point of this chapter is the choke coil. You will get question on choke coil. Remember what is a choke coil? Oops. Remember, a choke coil is a combination of L and R. Remember, the choke coil is combination of L and R. You must have seen on that Purana tube lights, you had this big choke, big dabba. That is a choke coil. It's a combination of L and R. A choke coil used to control current in AC circuit at negligible power loss is based on the principle of wattless current. What is wattless current? L is very high, R is very less. L does not consume any power. That current which L consumes or C consumes is known as wattless. Iron core choke coil is used generally at low frequency. Low frequency XL is very low. And air core at high frequency. This is just for your information. Remember, choke coil is a LR circuit. Choke coil is a LR circuit. Choke coil is a LR circuit. You must remember this. Straight away question will come. Please note this down. And then we can move on to some more question. To some more questions. I hope you are noting this thing down. I'll give you a minute to note this. I've seen many questions of choke coil and I found one. So we will be doing that question and you will keep it as a fact. Remember, most of the question that is going to come on your AC will be based on facts. Numericals are very less. Numericals may not come. They will either give you a graph. They will ask you what is resonance frequency. We have covered almost all of them. We have covered all of them and you must be confident that you would be able to crack it. Oh, I should not say crack it. I would say crush it. You will be able to crush any question that comes in AC. Now, we move on. I hope you have written this. Now we move on to a question, and this question came in AIMS 2001. The coil of a choke in a circuit. Choke coil. The coil of a choke in a circuit. What does it do? Increases the current, decreases the current, has high resistance, does not change the current. And remember, the answer for this one is any choke that you put, it decreases the current, it regulates the current. That means it decreases the current. So remember these points. As I told you, most of the question that you will find are simple, straightforward ones based on knowledge. Or if a numerical comes, as you can see, the numerical is very simple. This is the numerical that comes. This is NEET 2011. In a AC circuit, an alternating voltage of E is equal to 200 root 2 sine omega t, 100t, is connected to a capacitor of capacity 1 microfarad. What is the RMS value of current? What is the RMS value of current? This is as simple as you get. This is a pure capacitive circuit. I hope you can tell me the answer. Simple question. Cannot speak, so I'll have to do this question. How will I do it? This yellow thing is E naught, maximum value. This green thing is your omega, 100 is omega. So I have E naught as 200 root 2 and I have omega as 100. I have to find out the value of RMS current. So first I will find XC. XC is 1 by omega C. All of us know this. I can calculate the value of XC. I can calculate the value of XC. So it will be 1 divided by omega is 100 into 1 microfarad. It is 10 raised to the power minus 6. 100 into 10 raised to the power minus 6 is 10 raised to the power minus 4. 10 raised to the power minus 4 goes up. So my XC becomes 10 raised to the power of 4. My XC becomes 10 raised to the power 4. From here, I can find the value of ERMS or VRMS. My ERMS or VRMS becomes E naught divided by root 2. So it becomes 200. ERMS is 200 and XC is 10 raised to the power 4. Divide 200 by X by 10 raised to the power 4 and you will have your answer. You will have to just look at the units and tell me the answer. 200 divided by 10 raised to the power 4. Look at the units, tell me the answer. This definitely cannot be the answer. This definitely cannot be the answer. Just have to choose between 20 milliamps. Milli is 10 raised to the power minus 4. 20 milliamps or 200 milliamps. Milli is 10 raised to the power minus 3. And if you apply some brain, you will get that the answer is the blue one. And the answer is A, which is 20 milliamps. How I have done this question? E naught is 200 root 2. From there, I found the value of E naught, 200. Omega is given as 100. From there, I find the value of XC. XC is 1 by omega C. I multiply. I find the value of XC as 10 raised to the power 4. To find the value of EMS current, RMS current, I divide ERMS by XC and I get my answer. Do we understand this? I hope you are able to understand this simple question with a simple answer. Moving on to the next question, and this is the next question. A AC voltage is applied to a resistance R and inductance L in series. R and the inductive reactance both are equal to 3 ohms. So inductive reactance and resistance both are equal, both are 3 ohms. What is the phase difference between the applied voltage and current? So to find the phase difference between applied voltage and current, and tell me the answer now. Your time starts now. What is the phase difference between voltage and current? This is the LR circuit. It has R and it has L. What will be the value of phi? You all know to find out the value of phi. Tan of phi is XL divided by R. Here XL is 3 ohms. R is 3 ohms. 3 divided by 3. Tan phi is 1. If tan phi is 1, tan of theta is 1. The value of theta has to be 45 degrees, which is pi by 4. And hence comes your answer. The answer is C, pi by 4. As you can see, the questions that come in the examination hall are very, very simple. I hope you have understood this. I'll do one more question and I'll give you a minute to solve it. If you can solve it on your own, I'll be pretty happy. I hope you are solving the exercise on your own and you might have solved this question beforehand. A minute to win it. So how do we do this? Well, we go on as always. I have to find the value of XL. XL, inductive reactance. The value of XL is given as 20. The value of R is given as 30. So you can find out the value of Z. Z will be equal to 30 square. I can take 10 out. So it will be 3 square plus 2 square. 3 square plus 2 square. 3 square is 6. 3 square is 9. 2 square is 4. 3 plus 4 is 9. 9 plus 4 is 13. 10 is out. So root over 10 root 13. I divide RMS, ERMS by Z. So 200 divided by 10 root 13. 200 divided by 10 into root over 3 square plus 4 square, that is 13. 1 0 and 1 0 will cancel and the answer will be 20 root 13. That's as simple as that. And that is why I say that the questions that are going to come are very simple. But there's a small problem here. The answer is not D. The answer is not D. So this is all wrong. So I'll just rub it off. This is all wrong. The blue one is all wrong. What is the problem? The problem is this. 20 ohm resistance is at 50 hertz. But I am connecting it to 100 hertz. Now remember, XL, the value of XL is equal to omega L. L is constant. Frequency has been made twice, so omega also becomes 2 times. Omega becomes 2 times. Omega becomes 2 times. Omega becomes 2 times. Omega becomes 2 times. So XL also becomes 2 times. So XL at 100 hertz. At 50 hertz, it is 20. At 50 hertz, the value of XL is 20. So at 100 hertz, the value of XL would be 40. The value of XL is 40. The value of XL is 40. The value of XL is 40. Now remember my Pythagorean triplet. Now remember my Pythagorean triplet. One is 30. Resistance. Reactance is 40. So what is the value of Z now? 30 square plus 40 square, Pythagorean triplet. So it becomes, the value of Z becomes 50, not 10 root 13. I hope you are understanding this. 20 ohms was the inductive reactance at 50 hertz. Frequency is not 50 hertz. Frequency is 100 hertz. So it becomes 40 ohms. Reactance is 40 ohms. Resistance is 30 ohms. So impedance becomes 50 ohms. 50 ohms is the impedance Z. The value of RMS current? No. The value of RMS voltage is 200. What is the value of RMS current? 200 divided by 50. So the answer is B, which is 4 ohms. So you must remember this question. Maybe the same question can come to you in the examination hall. That is all from my end here. Is all that you need to know. If you missed anything, you can see the lecture. I'll see you in the next class. In the next class, we will be starting with KTG. KTG, kinetic theory of gases. Thermodynamics. You start with that. I'll see you. Probably your camera would be working, your mic would be working in the next class. I'll see you there. Till then, have a good day. Solve the other problems. The more the problems you solve, the better you will become. I'll see you on the other side tomorrow. Take care and have a nice day. If you have any doubts, you're always welcome to ask your doubts. I'm always there to help you out. Take care. Have a nice day.